Alright, on the parametrics review, the things you need to be able to do for the quiz. First thing is, given a set of parametric equations with parameters established, you need to be able to plug those t values in to get your x and y ordered pairs. Graph those ordered pairs. Don't forget if it does have a start and a stop, so this one started when t was 0, it stopped when t was 16, so make sure that I can see that there's a start and a stop, and then you also have to make sure you show arrows, draw a couple arrows to show me what direction it's going in. Don't forget if this went to, let's say, infinity, from 0 to infinity, then you would have to put an arrow on the end of it to show that it goes on forever. Okay, so just be careful if there is a start and a stop, or does that go to infinity. Alright, the second thing you have to be able to do is eliminate excuse me, the parameter. So, given a set of parametrics, you need to be able to solve for x in a problem like this. So I subtracted 1 divided by -1 to get t is 1 minus x. So you need to show me that work. And then you're going to take that value of t and substitute it in the other equation. Usually it's easiest if you can solve for the first equation for t using the x value, so you can plug it into the y equals right away. You can do either or, but eventually you have to get it to be y equals. So this would be an okay answer, but you have to identify that that's a parabola, because it's y equals x squared, and then you have to identify the vertex. So I do know it goes 5 down from this -5, but remember, to figure out how much it goes left and right, really what you're doing is you're factoring out a -1, excuse me, so then you're left with x minus 1 in here, which means it goes 1 to the right and 5 down. So the vertex is at 1, -5. If you see the a cosine and sine, that means it's going to be an ellipse or a circle. So you solve for the cosine of t. So this one I divided by 2. The second one I subtracted 1 and divided by 3. And so then once you've got the sine and cosine, what they're equal to, remember you have to use the identity that you need to know. Sine squared plus cosine squared is 1. So if cosine is this value, x over 2, so it's x over 2 squared, which simplifies to x squared over 4, and then plus sine squared, which is y minus 1 over 3 squared, which becomes y minus 1 squared over 9, equals 1. So when you get it in this form, you should see that since the denominators are different, it's an ellipse, and the center comes from here. It's at 0, 1. So you're getting this center from here, just like you do with a circle. And the number that's under the x squared term, that is how much it stretches horizontally. So horizontally, it's going to stretch the square root of that number. So 2 to the right and 2 to the left. So from the center, you would, after you know where the center is, you'd go 2 to the right and 2 to the left to get to 2 points on the minor axis. And then the number under the y, the square root of that, tells you how much you go up and down. So from the center, you would go 3 up and 3 down. So you can call that the vertical stretch, whatever you want to call that, but that is really how much you go up and down from the center. And the x number, this what's under the x squared, that tells you how much you go left and right. Alright, if these two numbers were the same, so let's say it would have been both over 4, then you could multiply by 4 and you'd have a circle, and the radius would be over here. Radius squared would be that 4, or whatever that number would be. If it's a line, if you have something like this over here and you end up getting a linear equation, then just tell me the slope and the y-intercept. Otherwise, a parabola, you should know the vertex. Circle, you should know the center. Ellipse, you should know the center and the horizontal and vertical stretch. And circle, you need to know the radius as well. Okay, so that's making sure you can do a problem like that. Then there's going to be a problem where you have to do some kind of a setup for a parametric, but it's not a projectile one. So like this one says, you got 2 trains that are moving. I just had them go to the right. You could have them go any direction you want, but it's easiest if you just say, okay, they're both going in the same direction. This one was going 30 miles per hour. The other one was going 80. So when I set up the first train, x is going to be changing. It's the rate times the time. So 30 times t is the x motion. And y you can set to anything. It's any constant. I just set it equal to 0, but it could be any constant. It's going to stay constant if I'm just moving to the right. And then the second train was going 80 miles per hour, but it did say it left 2 hours later. So the time it's traveling is 2 hours less. So it's rate times time. And again, y can be anything. I assume you want it to be the same as what this one was. I don't really have them drawn that way because I wouldn't be able to see it if one was on top of the other one. But you can make those just as long as they're constant, they can be anything. So then it says at 3 p.m. Well, if you look at the problem, the first one started at noon. So if it started at noon, at 3 p.m. it would have traveled 3 hours. So not 30 times 3 is 90 miles. The second train was going 80 miles per hour and t minus 2. Again, if t is 3, that really means this train has only been going for an hour, which makes sense. It started really at 2 o'clock in the afternoon, so at 3 p.m. it's only gone an hour. So when I take 80 times 1, I get 80 miles, so now I see that they're 10 miles apart. And again, I just need to see that work, so make sure you're always showing me what you plug in, what are the parametrics to get your answer. All right. Number 5, there'll be a problem on the quiz where you have to use the projectile equations. I will give those to you. So it'll always give you the initial velocity and the angle in the problem I'll give you. So you know that information. So x is going to equal 180 times the cosine of that angle times t. Y is going to equal, if it's in feet per second, it's going to be negative 16 t squared plus 180 sine of 40 times t, plus the initial height, which was 3. So, setting those up, and then there's going to be 2 kinds of questions. One's going to be find the maximum height. So to find the vertex of a parabola, you just have to take the opposite of b. So b is that number right there in front of the t. So the opposite of b over 2a. And so when I put that on my calculator, I got 3.616 seconds. Label it seconds so you know that, okay, that's a time. Then I really want to know what is the height. So I need to know the y value at that time. So show me that you're plugging in 3.616 seconds into your y equation, and I get 212.2 feet. Make sure again you label that. How far does Lee hit the ball? So now you're thinking, okay, from where it started, where does it hit the ground? So first you have to figure out when it hits the ground, so that's the quadratic formula. So if I set my y value equal to 0, now I have to do the opposite of b, plus or minus square root of b squared minus 4ac all over 2 times a. So that's what I've got here. Again, you'll have to show me that. What I suggest you might do is on your calculator put 180 sine of 40. Take that number and store it into, let's say, alpha b, because then you can come back to it and say, okay, I need to take square root of alpha b squared minus 4 times negative 16 times 3. Get what that answer is. So then you'll do negative b plus that number divided by negative 32 and negative b minus that number divided by negative 32. So practice putting that in your calculator. I got 2 answers. It makes sense. One is negative because remember it started 3 feet above the ground. So if I were going to actually look at the parabola, there would be a negative time. So I ignore that, but write it down so I know that you have that number. You realize that that number doesn't make sense in our problem. The other number was t equals 7.26 seconds. One thing I didn't do here, I realized, is I did not put my work to get this answer. You should do that. So I should have written x equals 180 cosine 40 times 7.26. And I should have then gotten 1,001 feet, 1.07 feet. I do not tell you what to round to. I would say at least go to the nearest tenth, if not the nearest hundredth. But it really doesn't say what you have to round to on those. Okay, so that's really the quiz. Word problem, we have to find maximum height and how far they go. A word problem that is just a linear kind of problem you have to solve. 2 where you have to eliminate the parameters and tell me what kind of an object it is. And then 1 where you have to graph it and make sure that you show me the arrows and the things of a parametric.